Hello children, I'm teacher Rebecca Seraphim and I'll be teaching you chemistry this year. So welcome to class 8 ICSE chemistry. The first chapter in class 8 is matter. So what is matter? We've studied that matter is anything that has mass and occupies some space which can be felt by our sense organs. So matter is made up of tiny particles called molecules. These molecules are held together by a force called intermolecular force. There is also a space between the molecules called the intermolecular space. So matter is made up of tiny particles called molecules. These molecules are held together by a force called intermolecular force. And there is space between the molecules of a substance that is called the intermolecular space. Now the next point, the stronger the intermolecular force, the smaller the intermolecular space. Now what does this mean? That if the force of attraction between the molecules is very strong, so the stronger the force it is having, the space, the distance between its molecules will be very less. So stronger the intermolecular force, smaller will be the intermolecular space, that is the distance between its molecules. And weaker the intermolecular force, larger will be the intermolecular space. So if this force is not very strong, in that case the gaps or the spaces between the molecules will be larger. Now we have seen states of matter, that is solid, liquid and gas. We have seen various things around us that could be in solid state, liquid state or gaseous state. We also have two more states, that is the plasma state and the Bose-Einstein condensate. We have two more states of matter that have been discovered. One is the plasma state and one is the Bose-Einstein condensate. But we won't be looking into those states in this class or in this video here. Let's go to the next topic. Let's see solids. And what are solids? Let's see their properties. So we have come across many solids articles around us. The phone in your hand or the laptop in front of you, it is solid. What is the special character that defines a solid? Let's see. Solids have definite shape. So all solid substances will have a definite shape. They have a definite volume. So that is, they have a definite shape and definite amount of matter inside it. So they have a definite volume. Maximum force of attraction between the particles. Solids have maximum force of attraction between its particles. That's why they are known to be rigid. They cannot be compressed. Now, since the force of attraction between the particles is maximum, that means the intermolecular space is minimum. And because the spaces are already minimum, they cannot be compressed. So already they are very close to each other. The molecules are too close to each other in solids, so we cannot compress them further. Kinetic energy of particles is minimum. So in solids, the kinetic energy. Now what is kinetic energy? Energy due to movement of particles. Every particle, be it in solid, liquid or gaseous state, is in continuous movement. But in case of solids, this movement is minimum and hence the kinetic energy is minimum. Particles cannot move, rather they vibrate at their fixed position. Actually, there is no movement in solids of their particles, but they just vibrate along their fixed position. Highest density. Solids are known to have the highest density. And why they have highest density? Because they cannot be compressed. The spaces between them are very less and hence the density of solids is very high. It's the highest among the three. Solids cannot flow. Since solids are rigid, they have a fixed shape. They do not need a container. They can contain themselves. They have their own shape and they will not flow. They do not flow. Let's see the characteristics of liquids. Liquids have indefinite shape. What does it mean? It can take the shape of the container. As we see in the picture, we have got different conical flasks, round bottom flasks and test tubes. So the different liquids present in them are of the shape of the container. Definite volume. Although they have an indefinite shape, they have a fixed volume. So we cannot change the volume of liquid just like that. The less forces of attraction between particles as compared to solids. So among the liquid particles, the force of attraction is lesser than that it is that of solids. In solids, we have more force of attraction between the particles. Here it is lesser. Why it is lesser? Because the distance between the molecules is a little larger than that of solids, and that's why the force of attraction is lesser. They cannot be compressed. So just like solids, even liquids to a great extent cannot be compressed, because although there is a space, but there's not much space, so they cannot easily be compressed. Kinetic energy of particles is more than that of solid. Now, since the distance between the particles is a little more, hence the kinetic energy, that it has more space to move and it moves. So kinetic energy of particles in liquids is more than that of solids. The particles can slide over one another. So we see that particles of liquid can just slide over one another. The density is lower than that of solids. So since in solids the particles are very close to each other, the density is very high. Here they are at a little distance from each other, and hence the density is lower than that of solids. And liquids can flow. The unique quality of liquids to flow, and liquids will generally flow. They generally flow from a higher level to a lower level. Liquids will always flow from a higher level to a lower level. So these are the characteristics of liquids. Let's see for gases now. So the first point here, they have an indefinite shape. Gases have indefinite shape, so they do not have a particular shape. Next is, they have indefinite volume. Now when it comes to gas, there is no fixed volume for gas. It can take the shape of the container. It can occupy all the space present in the container. It just spreads. Negligible force of attraction between the particles. Now why does a gas spread inside the entire container even if it is a very little quantity? Because there is negligible force of attraction between its particles. Its particles are free to move. So gas can be compressed. So unlike solids and liquids, gases are highly compressible. The reason being they have a lot of intermolecular spaces, and hence they can be compressed. Kinetic energy of particles is maximum. Now since the distance between the particles is maximum, their kinetic energy is maximum. Particles can move freely. So because of high kinetic energy, more distance between them, the particles of gas are free to move. Lowest density. Gases are known to have the lowest density. Naturally, the particles of gases are far apart from each other, and hence its density is the lowest. Gases can flow. Gases can diffuse very easily. So what is diffusion of gas? When it just spreads into the entire container without any kind of force added, without any kind of a stirrer, without any kind of a blower, gases just move around from one place to another, and that's called as diffusion. So once again, we can see the characteristics of solids, liquids and gases. Solids have a definite shape, definite volume, maximum force of attraction between particles, cannot be compressed, kinetic energy of particles is minimum. Particles cannot move, rather they vibrate only at their fixed positions. It has the highest density and it cannot flow. For liquids, liquids have indefinite shape, they have a definite volume, less forces of attraction between particles compared to solids, cannot be compressed, kinetic energy of particles is more than solids, particles can slide over one another, density is lower than solids, and liquids can flow. When it comes to gases, the properties are they have indefinite shape, indefinite volume, negligible force of attraction between particles, they can be compressed, kinetic energy of particles is maximum, particles can move freely, they have the lowest density, and they can flow and also they can diffuse. Now let's go to the next topic, that is interconversion of states of matter. Means, can matter be converted from one state to another? Yes, and we have seen that in our earlier classes also. The change in state of matter from one state to another is called the interconversion of state. What does this mean? It means that if you take a solid and heat it, it will convert to liquid. Liquid, if you heat it, it will go to a gaseous state. We can see that with this example in this picture here. Ice is taken, heated up. If you heat ice, we'll get water. If water is further heated, we'll get water vapor. If water vapor is condensed, if it is cooled, we'll get water from it. And if water is cooled or refrigerated, frozen, we'll get ice back. So this conversion of state of matter from one state to another is called as interconversion of states of matter. Now let's see kinetic theory of matter. First one, every matter is made up of very tiny particles called molecules. Molecules of a particular substance are alike, while molecules of different substances are different. Second, molecules of matter are always in a state of continuous motion. As a consequence, molecules have kinetic energy due to motion. Third, the kinetic energy of molecules depends upon the temperature. If the temperature is increased, the kinetic energy increases. The fourth one, molecules of matter always attract each other. The force of attraction between the same kind of molecules is called force of cohesion. The force of cohesion is helpful in keeping the molecules of the substance together. The force of attraction between different kind of molecules is called the force of adhesion. The next point, fifth one, the distance between two molecules is called intermolecular distance. The next sixth one, the force of attraction between molecules, either cohesive or adhesive, is called the intermolecular force of attraction. Seventh point, the intermolecular force of attraction is inversely proportional to the intermolecular distance. The force of attraction increases when intermolecular distance decreases. This is an important topic. Kindly we'll go through the points carefully. First one, all matter is made up of very tiny particles called molecules. So matter is made up of very tiny particles called molecules. In the solid state, the particles are rigidly held in positions about which they can only vibrate. So when it comes to solid state, the particles are rigid. They are rigidly held about those positions which they can only vibrate. Means they can only vibrate. They are not free to move from one place to another. In the liquid states, the particles are in continuous motion, but they are not completely separated from each other. While in motion, they collide among themselves. So in liquid states, the particles are in motion, but they are not completely separated from each other. They are not free to go from one place to another totally. So while in motion, they collide among themselves. The next point. In a gaseous state, the particles are in continuous random motion, almost independent of each other. So in gaseous state, if you see, we see that the particles are in continuous random. There is no direction. They keep on moving in any directions. Wherever they come across another molecule of gas, they will collide with each other and again go in opposite directions. So it looks like a game of a pool table or billiards game. Similar kind of a action is seen. So this movement, zigzag or random movement, is also called the Brownian movement. It is also called the Brownian movement. The particles of a gas can travel much longer distances than in liquid before they collide with other particles or with the walls of the vessel. So why gas has this unique property, or why it has high kinetic energy? That is because its particles travel longer distances than liquid. Why they travel longer distances? Because they have larger intermolecular spaces. So they travel longer distances before they collide with another particle of gas or with the wall of the container. Wall of the container could be the wall of the vessel. The collisions of the particles with the wall of the vessel give rise to pressure of the gas. We know that gases exert pressure. Why do they exert pressure? They exert pressure because of these collisions. Gases are free to move inside the container. So as they come across, they hit the walls of the container, they collide with the walls of the container. This gives rise to pressure which builds inside gas. The next 2 points of kinetic theory of matter. First one, the particles possess some energy due to their motion. This energy is called kinetic energy, or as already discussed. Because of movement, because of motion, the energy that is there in the particles, this is called as kinetic energy. The kinetic energy possessed by particles is dependent on temperature. Now this kinetic energy is dependent on temperature. If we increase the temperature, that is higher the temperature, higher is the kinetic energy. So if you heat a gas, if you heat a solid, heat a liquid, the movement will be faster. Okay, so that will give a higher kinetic energy. So when the temperature increases, kinetic energy increases, and lower the temperature, lower is the kinetic energy. So if you decrease the temperature, the kinetic energy of molecules will decrease. So these are all the points for the kinetic theory of matter. Now let's go to the next topic, that is solid-liquid interconversion. Let's see what happens in a solid-liquid interconversion. So as solid is heated, the kinetic energy of the particles increases. With the rising temperature, the particles vibrate more and more vigorously till they move away from their fixed positions at a particular temperature called melting points. Now, how does solid convert to liquid? We said that within solid, the particles move only around their fixed path. But if you start heating a solid, as the temperature will keep on increasing, the distance, first of all, the vibration will increase. They will vibrate more vigorously. And because of this vigorous vibration, they will start moving away from their fixed positions. So slowly by slowly, this will give rise to more intermolecular space. And what is the difference between solid and liquid is only the distance between the intermolecular space. Solids have no distance, hardly any distance. But if there is some distance created, then it's going to get converted to liquid. So with increasing temperature, there will come a point where the solid will reach a particular temperature, which is called the melting point, where the distance will be equal to its liquid state. So when the molecules of solid will move apart, will start moving apart and reach a distance which is going to make it into a liquid state, that is called the melting point. So the only difference between a solid and liquid is the distance between its molecules, the distance between its molecules. So more the distance, it's going to change the state. So if the temperatures increase, solid will get converted to a liquid at one point. Please note that every substance has a different melting point. So melting points are different for different substances. Now let's see interconversion of liquid to gas. So similarly, as the temperature is raised, the kinetic energy of particles increases. And as the particles collide more strongly, this leads to faster evaporation of the liquid. At the boiling point of liquid, the kinetic energy of particles becomes so great that all particles tend to escape. Thus, at the boiling point, entire liquid may convert into vapor. So what happens? So once a solid is converted to liquid, and you start heating or boiling the liquid at a particular temperature, every molecule starts moving apart. So more and more distance is created. More distance is created between the intermolecules or between the molecules of the liquid. This gives rise to reaching a particular temperature that's called as the boiling point. So as the vaporization point. So once it reaches its vaporization point, it will convert into vapors. So at boiling point or at vaporization point, it will convert into its vapors and convert into gaseous state. So what's happening actually here? The distance is further increased to reach the distance that is there in the gaseous state. Now let us see the conditions of change of state. The conditions of change of state differ from substance to substance. As I said, the melting points or boiling points for every substance will be different. For example, the boiling point of water is 100 degrees Celsius, while that of ethanol is 78 degrees Celsius. It is not that everything is going to boil at the same time. Ethanol will boil faster than water, and the difference of temperature is around 22 degrees Celsius. This is because the intermolecular force and the intermolecular space differ from one substance to another. Every substance has a unique intermolecular force and its unique intermolecular space. Since these differ, the boiling points or melting points of that substance differs. Now let us see the law of conservation of mass. It's a very important topic. Kindly pay attention. Matter can neither be created nor be destroyed, but it can be changed from one form to another, and the total mass of substances before and after the change remains the same. So once again, what is law of conservation of mass? Law of conservation of mass states that matter can neither be created nor it can be destroyed. So we cannot create matter out of nothing, or we cannot even totally destroy matter. Okay, but it can be changed from one form to another, and the total mass of the substance before and after the change remains the same. So when we are talking chemically, suppose you say I took a piece of paper and I burnt it. I have destroyed the paper. But the paper is destroyed, children. The matter has not been destroyed. How? Let's see in the examples. Now when we are talking about physical change, let's see the first thing. Mass of an electric bulb does not change after it remains lighted for some time. So if you switch it on and switch it off, it's a physical change. But the matter or the mass there does not change. So law of conservation of mass holds right for even physical change. Mass of ice on melting gives the same mass of water. So when we have a particular amount of ice and it is melted, it gives us the same mass of water. Mass of water on boiling gives the same mass of water vapor. So if you boil water, you're going to convert everything into water vapor, and if you check the mass of water which you took to boil and the mass of the vapor will be the same. So the law of conservation of mass holds right here, that due to any physical change, we cannot change mass, or matter cannot be created nor be destroyed. Now let's see with regards to chemical change, and coming back to the example that we discussed before. So first, whenever a chemical change takes place, the sum of masses of the reactants in the chemical is always equal to the sum of masses of its products. So when we are having a chemical change take place, we have studied in our previous class that whatever reactants are there, they may give rise to different products. But if you take the total mass of the reactants and total mass of the products, the total will always be the same. So this we can say proves that mass cannot be created nor be destroyed. Matter cannot be created nor be destroyed. So we just saw that example. If you take a piece of paper and burn it, what is the chemical reaction that is actually happening in that? If you take a paper and burn it, it is the mass of the paper plus the oxygen that is going to react. What is burning? It is combustion. What is combustion? It is reaction of anything along with oxygen. Mass of the paper will be now mass of the paper plus the oxygen that was used to burn it. If you calculate both the masses, it will be equal to the mass of the ash, mass of carbon dioxide, and mass of water vapor all together. So matter cannot be created nor be destroyed, but it can be changed from one form to another. So it must be a very important paper. The paper would have been destroyed, but as per the law of conservation of mass, the mass was not destroyed. It has only changed its form. So let's see the points to remember. Let's recap the whole lesson, what we have learned till now. So the first point is matter is made up of tiny particles called molecules. Then The space between these molecules is called intermolecular spaces. The greater the intermolecular force, smaller is the intermolecular space. So if the intermolecular force is more, the space is lesser. The three states of matter that we have seen today: solids, liquids and gases. Solids on heating can be melted to liquids, and liquids on cooling can be transformed to solids. So this is the interconversion of solids. So if you heat solid, you can get a liquid. If you cool a liquid, you can get back the solid. Liquids on heating can be transformed to gases, and gases on cooling can be transformed to liquids. So this is the interconversion of liquids. Liquids when heated give us gases, and gases on cooling can be transformed to liquids. Liquids can vaporize below its boiling point. The process is called as evaporation. So when liquids vaporize below its boiling point, it is called as evaporation. The particles of matter possess kinetic energy. Very important to note that all matter, whether solid, liquid or gas, they have kinetic energy, and the kinetic energy is maximum in case of gases. Kinetic energy of particles increases with increase of temperature. So when the temperatures increase, the kinetic energy of particles increases. Kinetic energy of particles decreases with the decrease in temperature. So if kinetic energy is decreased, the temperature also is decreased. So it is interrelated. Kinetic energy increases with temperature and it decreases if the temperature is decreased. So I hope that all these points are clear. Thank you.